Welcome to the Learning Pines YouTube. We hope this video helps.
You start by listing what you know: initial speed v0, launch angle theta, and launch height h0. Write down horizontal and vertical components immediately. v0x equals v0 cos theta, and v0y equals v0 sin theta. Once done, set gravity g as positive magnitude, 9, 8m/s2, and define downward as negative in your equations. Make sure to record units and sign conventions now, because inconsistent signs are the most common source of error later when solving for. Next, you focus on time of flight by using the vertical position equation y t equals h0 plus v0 yt minus 1/2 gt2 and setting yt equal to the impact height, often 0. Rearrange into a quadratic and solve for t. You want the positive root. Once done, verify the discriminant is non-negative. If it is negative, recheck inputs and units. Make sure to keep track of signs so your selected route corresponds to a future time, not a prior one or the launch instant. Finally, compute the velocity components at impact. Horizontal stays Vx equals V0x, assuming no air resistance, and vertical is y equals V0y minus gt impact. Then combine them. V impact equals sqrt, Vx2 plus y2 to get speed, and theta impact equals arctan, y/Vx if you need direction. Once done, make sure to double-check units and the sign of y. Troubleshooting tip: if y seems unrealistically large or imaginary, reevaluate the chosen route for time and your.
Thanks for watching. Consider subscribing if we helped you.